about the integumentary system, its different functions, the different things that we can find in the integumentary system, and how they all work together in order to make our integumentary system what it is or what we know. Um, so, starting off, the integumentary system, which I've said in previous videos that our skin is our largest organ. That's because it is comprised of different cells, different tissues that make up the organ. Also, our skin is the barrier, or is our first line of defense from the outside world. So that is our first defense. So that keeps us away from bacteria, things that can possibly harm us that are from the outside world. So skin is our largest organ. Most people think it's our liver, but it's really actually our skin. So the integumentary system, as it states in our book, it states that it is 7% to 8% of the body weight, and it covers the entire body surface. So that's one reason why it's so important when we get like a cut or some type of abrasion or laceration, that we keep it clean and keep it um, sealed from the outside world so that it does not essentially harm us. If we allowed it to remain open, things like bacteria and other parasites or things that could potentially harm us could get inside of us and cause the tissues that are on inside of us to become infected, and then we have a bigger issue. So that's one reason why skin is such an important organ. So if we actually take a look a little bit deeper into it, we see we have some hair up here, which the part that we actually see that of the hair that actually peeks out above the skin is actually referred to as the hair shaft. And here we can see we have our sweat pores, which is the top portion or the little hole that actually comes out the top of our skin. But more importantly, the skin is actually broken down into a few layers. So you have your epidermis, and if we remember correctly, epi means above or the surface, which that would be correct because this is the top layer of our skin. Then we have the dermis, which is going to be the middle layer of our skin, which is where a lot of our blood vessels and sebaceous glands, um, a lot of our arteries and veins, a lot more of our other structures are going to be in the dermis layer. And then you have your subcutaneous, which they don't really classify as a subcutaneous layer as part of the integumentary system, just because it has a lot of fat, which is where all these little yellow cells are down here, which is adipose tissue. They don't really actually consider this to be an actual component of the integumentary system, but it's still needed for it, though. It's still needed for heat retention. So on this side here, we see we have an erector pili, which is this muscle that is connected to the hair follicle, which anytime you ever get goosebumps or you get cold and your skin tenses, or even if you're scared, this muscle here is attached to your hair follicle, and actually what makes your hair stand up when you get cold or you get scared. It causes your skin to get tighter, which actually provides more heat retention. And then we have some sebaceous oil glands, which usually you'll find them around your hair. And then we also have some different types of sweat glands. So you can have apocrine or eccrine sweat glands, which we'll get into later in this chapter. Um, but here's just kind of a basic overview of what the skin looks like underneath the surface. So we think of skin just being what we see on the outside, but the skin actually goes a lot deeper. So in the epidermis, which is the very top layer, it's actually made out of a few different layers. So here in this picture here, we can see that the epidermis, which is that first layer that we saw on top right before the dermis, ergo the name epi, that actually has a few different layers. So we have the basal layer or the stratum basal, the stratum spinosum, stratum granulosum, stratum lucidum, and the stratum corneum. And they actually gave it to you in order, starting from the bottom. So here we can see this, the dermis, which is that middle layer. If we work our way up, we have the stratum basal, which would be the basal layer or the base layer. Go up another layer, we have the stratum spinosum, another layer that would be the stratum granulosum, the next layer, the lucidum, which the lucidum we may see in some skin cells and some not. And then the top layer, which is the most superficial layer that we actually all see, is the stratum corneum. And that layer is usually the thickest because it has the most dead skin cells. They're about 20 to 30 cells thick. So that the layer that we actually see is actually pretty thick. It actually has about 20 or so plus layers. And that's the part that we come in contact with. That's the part that gets scratched. So it has to have a lot more cells to prevent harm from the rest of the skin. And here it actually gives us a little bit more organelles. We have a melanocyte, which is what produces the melanin of our skin. So that's what makes me my color. That's what makes you your color. So melanocyte is what actually produces melanin. And then you have tactile cells, which tactile is if you think about like a thumbtack and how if you were to take a thumbtack and like barely touch your finger, you could feel that. That is what tactile is. It's for very light, sensitive touch, which is usually going to be on our fingertips. And then you have sensory nerve endings. And nerve endings are interesting because just to give you an example, if you were to get a paper cut, even though you're not bleeding because you didn't go into the dermis, you've cut just barely enough to where it has touched one of those receptors and it can actually hurt, even though you're not bleeding, even though you haven't really cut that deeply. But those areas that are super sensitive actually have a lot of nerve endings. So going by layer, so in the stratum basal, which was that very base layer coming up from the dermis, you have what's called keratinocytes. If you can guess from that prefix, keratin is the protein keratin, then cytes would mean cells. So these are the cells that are going to produce keratin. So essentially the point of these are the stem cells that generate new keratinocytes, which replace dead keratinocytes that shed from the surface. So all these layers that you're seeing here, all these layers, all those cells start in the stratum basal layer. It's called basal layer because it has a lot of stem cells, and all those cells are going to push up into the next layer once they leave the basal layer. So once they leave the basal, they're going to push up to the spinosum, then they're going to push up to the granulosum layer, and then the stratum lucidum, if it has one. And then it's going to finally end up in the stratum corneum, which it'll steadily get pushed up and up and up until it sheds off. And this process happens constantly over and over and over again. So in the stratum basal layer, they produce or synthesize keratin, which is a protein that strengthens the epidermis considerably. Also, it makes it very tough and insoluble. Insoluble means that it's not able to dissolve. And so with keratin molecules, it can twist and intertwine and form intermediate helical filaments. So essentially, it just makes the skin stronger, and that's what we want. We don't want it to be very loose because remember, the skin is our first line of defense. That's the first thing that's going to protect us from the outside world. So we have to make sure that things can't get out and things can't get in. Melanocytes, like I said earlier, they're producing our melanin. Um, and there's actually two different types of melanin. There's phosphomelanin, and there's eumelanin. So if you're lighter complected, you have, I believe, phosphomelanin, which starts with a P. And then if you're darker like me or complected like me, we have eumelanin. Um, so when it comes to different colors or different shades, you can stimulate these melanocytes, which produce our melanin. They can be stimulated by going out into the sun. So we've seen that if you ever get a sunburn, you will see that your skin turns a different color. Or if you're out in the sun for a long period of time, your skin will actually get darker or turn a different color. So if you're lighter complected, it will turn Usually it'll turn red. And then if you're darker like me, you'll just turn to a darker shade, just about like the color of my shirt. Depends on how long you stay out there in the sun. Um, Tanning can actually be a bad thing if you're out there for too long, especially if you're not wearing sunscreen. That can actually start to mutate your DNA, and that's not something we want. We want to be able to keep our regular DNA because if you get ready to have children, it can get passed down to your children. So also smoking can cause your DNA to change a little bit. If you go into a tanning bed, you can mutate your DNA. You can also end up with skin cancer. Um, so so melanin and melanocytes have a big role to play when it comes to protect us from UV radiation and also the sun in general, or it's just sunlight. If we go into the spinosum layer, and it's referred to the spinosum layer because it has essentially it looks spiny, like looks very pointy. Um, so once the cells leave the basal layer and go up into the spinosum layer, they begin to differentiate into non-dividing and highly specialized keratinocytes. So in the basal layer, they're stem cells, which means they can turn into any type of cell that they want to. But as soon as they go up into the next layer, in the spinosum layer, they're not able to. They can only become skin cells, and that is it. And so um, the keratin in there starts to change. Um, and as they go up, we'll see that the keratin starts to change even more. So now we're going up. So now we've left the spinosum layer. Now we're going up to the granulosum layer, um, which it gets its name because it's the granule layer, which it looks like a bunch of granules. It looks kind of rough, so that's how it got its name. So in this layer, keratinocytes synthesize significant amounts of proteins or keratin. So in this layer, this is where they start getting a lot of protein development or keratin development, which is going to make these cells a lot stronger. Now, with a high production of keratin, it's going to cause the organelles in those cells that we talked about in chapter 4. It's going to make some of those organelles kind of get knocked out the cell because it has to make room for keratin. So those organelles start to disintegrate, which essentially is going to kill those cells. And you're thinking, well, we want to keep those cells. Well, remember, our cells that are on the surface of our skin are dead skin cells. So this is actually how they die. So they die by essentially pumping in a lot of keratin, which is going to make them stronger. It doesn't necessarily need to be living to be stronger. It just needs to be stronger. So all of our dead skin cells kind of start dying in the granule layer. And then the next layer up, and this is only if you have this layer, depends on which part of the skin you're referring to. So the stratum lucidum is also referred to the clear layer. And this layer is actually only found in like the palms of your hands and the soles of your feet. So this white layer, if you ever wondered why this layer or your palms of your hands are always white, and then the rest of your hand or the other parts of your body is a different color. One, it doesn't have any melanocytes, and also is that it has a lot of clear, um, translucent cells here. So this is why it's always white-ish. Um, so in this layer, if you do have it, it's usually going to be thicker just because it's going to be on the soles of your feet. So this is where there's going to be a lot of abrasion. So this essentially makes that part or that region of the skin a lot stronger because it knows that it's going to be essentially touching a lot or rubbing against something a lot, picking up things, getting kind of rough. So it makes a thicker layer. And this also, by having this thicker layer, it actually protects from ultraviolet lights. Also, if you have a callus, like especially if you've been working with tools and your skin cells around your palms of your hands start getting thicker, this is actually what's happening. You're actually seeing this layer really get thicker to protect from your skin essentially ripping and coming apart. So calluses are just a result of just your skin getting thicker. It's actually making more cells, so that it protects it from getting, I guess, brazed or rubbed or essentially torn. And then the last layer, which is the very outer layer, which is the skin that we have here, is going to be your corneum layer. Um, Now this layer again consists of about 20 layers, 20 to 30 layers of dead, scaly, interlocking skin cells. These skin cells have a lot of keratin in them, and they are anucleate, which means that they are lacking a nucleus. They do not have a nucleus because once we pumped all that keratin into them in the granulosum layer, there is no nucleus or any organelles at this point. So those skin cells essentially die off at that point. And so that's how we get our different layers. And this is why when we get to the very top, we refer to it as dead skin. And that's why we have to kind of make sure it stays clean. And why every time, even when you shake someone's hand, you're getting someone else's dead skin cells. Um, a lot of the dust that is in our house, I believe is nearly 60 to 70% of that is actually skin cells. Um, so we leave skin cells everywhere. This is one reason why it's important to wash your sheets and, vacuum your carpets and clean your floors, because you have dead skin cells everywhere. So it's interesting of how our immune system works, and we lose a ton of dead skin cells a day and don't even recognize it. Especially when you go get in the shower, when you shake someone's hand, when you're sitting down, when you're sleeping, dead skin cells are just shedding off of you constantly. Also, the corneum, not only is it's a thickened surface that's very unsuitable for microorganisms or bacteria to grow. Um, so your sweat, your oil glands, they actually help prevent um, bacteria from growing. Um, However, you still have to keep it clean. So this is one reason why oils are or your skin being oily is a good thing. However, we don't want it to be oily for too long, because not only does it trap bacteria, if we don't get rid of that bacteria after it's trapped it, it could potentially clog up our pores, which is going to cause acne and things of that nature, which we get to talk about in this chapter. But that's one reason why it's good to keep your skin clean. So in terms of thick skin versus thin skin, so the only difference is the thicker skin has a stratum lucidum, like we said earlier. Um, but it ranges between 1.5 millimeters to 4 millimeters, and then 1 millimeter and 2 millimeters. So usually the thicker skin is going to be where there's going to be a lot of um, essentially exertion, or where there's going to be a lot of movement. You want to be able to endure that roughness, I guess, like for a better term. Um, So thin skin is going to be found all of our bodies. So on the skin on the back of our hands, on our face, on our chest, our neck, our legs, that's going to be thin skin, versus thick skin is only found on our sole, on our palms of our hands. In the tissues chapter, it talks about how we have um, the thicker skin, or the keratinized skin, or keratinized squamous cells, which were going to be on our palms of our hands. But we also have squamous epithelium on the inside of our mouth, but they're not keratinized. So keratin makes things rough, and then non-keratinized makes things soft. So on the inside of our mouths is non-keratinized, but on the soles and palms of our hands, those are keratinized. It makes things a lot rougher and be able to endure a lot more exertion. So skin color. So skin color actually comes from a few different things. It is hereditary, of course, but there are some other things like hemoglobin and keratin. So hemoglobin is the protein that's located in our bloodstream that's going to essentially bind the oxygen that we are breathing in and transport it throughout the body. So, especially if you're lighter complected, you'll see this a lot more than people like me. Um, if you are lighter complected and if you notice, like if you get embarrassed, you'll start blushing and then your cheeks start turning red. That is because you have blood vessels that are very close to the surface of your skin and they will essentially dilate, which means that those blood vessels become a lot bigger, which a lot more blood can flow through there. So the color of the red blood cells or the blood is because the red blood cells that we have, they're going just going to push a lot more blood through those blood vessels now that they're a lot more open and wider. So more blood flow means you, of course, you have more blood coming in, and so therefore you're able to see your blood vessels actually opening up, and you can actually see a lot more blood flow. That's why you blush. That's why the red color comes from. So in people who are lighter complected, you can see a lot more of their blood vessels because they're lighter complected, and so that's what you're actually seeing. So that's how hemoglobin can actually um, influence skin color. And then you also have melanin, of course. So with eumelanin, like me, would be for color with people who have a lot more color, that's browner or black. Um, pheomelanin would be for lighter shades of tan, yellow, and red. So everyone has melanin, but there's two different types of melanin. So it just depends on which one you have, but everyone has a melanin. Just like when just like when people go out in the sun, if you're lighter complected, you tend to turn red once you've been on the sun for too long. However, for people like me, we can get sunburned as well. It's a lot harder for us to get sunburned because our melanin is able to withstand a lot more sunlight. We're able to take in a lot more sunlight and heat. So therefore, we're a lot more resistant. However, our melanin will get darker, which just means that we get darker. So essentially, I can go from my complexion to the complexion of my shirt, but I don't run the risk of sunburning as easily as my lighter counterparts. Now, we still need, now, even as me, I still have to wear sunscreen because we can still, of course, get a sunburn, but it takes a lot longer for me to get a sunburn than someone who's lighter complected. So that's due to our melanin. We all have melanin. It's just we have different types of melanin. Um, Carotene. So carotene is a yellow orange pigment that we can get from vegetables. So you may have heard of a myth where if you eat too many carrots, you could potentially turn orange. Well, that's not a myth. That's actually a real thing. If you do eat too many vegetables that have carotene in them, your skin can actually turn that color. However, um, there's two different types of carotene. So you have alpha carotene and beta carotene. So beta carotene is going to be the source, or the primary source of provitamin A, which I think our skin is actually going to turn provitamin A into vitamin A. Well, excuse me, the liver does, um, which plays a role in our vision. So that's why they say if you eat a lot of carrots, um, it could potentially help your vision. Now, it does not mean if you're unable to really see or you have a issue seeing that if you eat carrots that it will reverse that. When I was younger and I was probably in the fifth grade, my vision had started to change. And so I started chugging or really just really eating as many carrots as I possibly could. Every time I was in the lunch line, I'd ask for double carrots every single day. And I still, of course, as you see, I end up with glasses. So it doesn't reverse what's already going to happen, but it does maintain the health of your eyes, though. It will protect it from getting worse or like glaucoma. It can protect the health of your eyes, not necessarily it can't prevent genetics. Because my mother and my dad were both wear glasses, so I'm like, inevitably, I was going to have glasses. And I thought that eating carrots, I could reverse that, but that's not how that happened. Ergo, the name Nutty Professor, that was because I guess I was nuts. But Anywho, but vitamin A essentially it helps the health of your eyes, and we get that from foods. So when it comes to radiation, which we have what's called UV radiation, which we get from the sun, but there's different types. There's A, B, and C, um, which it goes into the different wavelengths that they do give off. However, UVA and UVB do reach the surface of skin. And so UVA is commonly termed as tanning rays, and then UVB or UVB is termed as burning rays. Um, Either way, they're still kind of bad for you either way if you have too much of them. So tanning salons, especially in the early 2000s, which was a big, I guess, a fad or fashion of people getting to tanning beds that essentially made synthetic UV lights or just really essentially were UV lights, would essentially cause the melanin in your skin to get darker, and that's how you get tanning. They recently have stopped that because we understood that if you gave your cells too much UV radiation, you could potentially cause skin cancer. And we usually notice that happening more predominantly in people who were lighter complected. People like me, we didn't really get into tanning beds. As soon as we go out into the sun, our skin can change colors. But people who were lighter complected, they would usually get into tanning beds to become a little bit, fairer skinned or darker skinned. And if you did it too often, the body essentially would kind of reject it, or you start mutating those cells in your DNA in your cells, and then it starts causing your DNA not to form correctly, and then the cells start not copying correctly, and then you end up having cancer. Um, so that's one major downfall actually using a tanning bed, which I'm not seeing too many tanning salons anymore. Now, what they do have more than anything is sunless tanners or bronzers or spray tanning. Um, this is a better alternative than using a tanning bed. However, you still have to use sunscreen because it doesn't actually protect you from the sun. It makes your skin darker because it's reacting with the amino acids in your skin, so it makes you darker per se, but it doesn't actually protect your skin any. So with sunscreen, we all know that it has what's called an SPF, which stands for sun protection factor. And so it kind of gives you like a little formula that they use to understand SPF. So with SPF of 15, it will delay the onset of sunburn in a person who would otherwise burn in 10 minutes to 150 minutes. So essentially, it's a ratio between if you didn't wear sunscreen versus if you did wear sunscreen. So if you were, let's say you were standing in line in Hurricane Harbor, trying to get in, within that first 10 minutes, you're already burning. After 10 minutes, your skin is burning at that point without sunscreen. However, compared to a person who did put on SPF 15, they wouldn't start burning until 150 minutes, which is essentially a little over 2 hours. So that is just from SPF 15. That is a major difference from not putting any on at all. 10 minutes, if you don't put any on for 10 minutes, your skin is burning at this point. But if you put some on, it just says SPF 15, which is a pretty low SPF, because usually we get SPF 30 or up, or even 100. If you use SPF 15, you're good for 150 minutes. So it's very wise to put on sunscreen. Now, sunscreen doesn't just have to be worn on the inside or the outside. You can also wear it on the inside, especially if you work in areas where there's a lot of light. They actually recommend that you use sunscreen too, even if you're indoors, because lights, even like the light right now, if you're exposed to a lot of light, especially like a lot of harsh light, your DNA, your cells can still react, even though it's not UV radiation. it's still light, and so it can still cause your DNA and your cells to denature. So the more you know, more you know. So there's some different types of disorders that can happen with skin color. So we have albinism, or if you may have heard someone being albino. Essentially, this is a inherited recessive gene that can be given from parent to child, and essentially it stops the enzyme, or there's an enzyme that stops melanin production. So essentially, it stops your melanocytes from producing melanin. And if you're not able to produce melanin, everywhere you produce melanin, such as your skin, your hair, even your iris of your eyes, which gives us our eye color, all of that has melanin. Anytime you see color within us, there's some type of melanin that is there. And so if you have an enzyme that stops the production of that, you have no color. So that's why you typically will see people who are albino with very pale skin. Sometimes they have their hair is even essentially pale or almost even blonde kind of in a way, or white hair, pale skin. Their irises in their eye can actually be pink, which is kind of cool, but it just means that they have no melanin. So typically people who are albino tend to not like to be on the sun because their body doesn't produce melanin. And so that is melanin is essentially the component that's going to help block UV radiation and also protect our skin to a certain extent, but they don't have any. So typically they usually have to wear hats and sunglasses and be really covered. If not, it essentially can start damaging their cells, their DNA, and it can cause a lot of issues. Moving on, so there's also skin markings. And so um, you may have one. So like a mole, which typically moles are not or are harmless. There's usually no big issue with them unless they start changing in size. I have one here on my arm. That's right here. I've had it since I was a child. It's been the same size, so there's no issues there. Some people refer to them as birthmarks because I was born with it. So as long as they're not becoming bigger, they're not an issue. Now, if you were to gonna go out into UV radiation or exposed to UV light and they start changing, that might be an issue. So you will want to go see a doctor of some sort or a dermatologist. But usually they're pretty much fine. Birthmarks or moles can essentially be anywhere on the body, anywhere that there's usually skin. I've even seen some people have a mole on their eye because remember, we have melanin in our eyes too. So they can actually be kind of anywhere. Freckles are essentially just localized area where there's melanocyte activity. It does not necessarily mean that there's an increase in melanocyte numbers. It just means that the place where we see freckles are just melanin. That's really it. It's just a place where there's melanin that is being expressed. And sometimes, if you go out into the sun with some people, you may have freckles pop up, and then once you stay out of the sun, they kind of go away. So now you understand why with melanin, when you go out into the sun, it becomes more productive. Um, and sometimes once we go back in and we stay in, they'll essentially go back away. Same thing with our skin. For people who are darker complected, we're able to become darker in the sun, but in the wintertime when there's not a lot of light and we stay inside, our skin can actually go revert back to its original color, but it can also go just a tad bit lighter too. So typically, on average, usually in the wintertime, especially in what region of the earth or region of the world that you're in, you can actually become just a tad bit lighter than your normal pigmentation. Pretty cool. So we have angiomas, which there's two different types. So you have what's called a capillary angioma and then a cavernous, cavernous, excuse me, angioma. So looking up here, which the one at the bottom is referred to as cavernous angiomas, which are also known as port wine stains. So here is a picture of that. So here you can actually see, if I can zoom in a little bit. Um, this is a type of birthmark essentially that actually will go away. So some children are born with this, and it's referred to as a port wine stain. And you can kind of see why, because it does kind of look like a wine stain if you spill it on something. However, these actually will go away. But here you can actually just see that there's a lot more vasculature. There's just a lot more blood vessels that are in this area that's closer to the skin surface. And so eventually it will go away. Um, Capillary angiomas are strawberry colored birthmarks and they appear in the skin bright red due to deep purple nodules. And they're usually present at birth and they can disappear in childhood. And this is what they look like. So if you see her face, you can actually see that there's a little bit of purple in this area. Um, Sometimes these actually do go away. Sometimes they can be there for life, unfortunately. Um, but you can see the reason why it's red and purple is because there's a bunch of more blood supply in that area. And then friction ridges, what we term these as fingerprints, but fingerprints is what's left behind after you touch something. But the actual things that actually make these little finger, what we call fingerprints, is actually friction ridges. And so they are found on our palms, fingers, toes, and soles of our feet and hands. They're thought that they, or the purpose of them is so that we don't slip and we're able to grip onto things. If you've ever noticed when you get out the bathtub or you're in a water or in a pool or in water for a long period of time, you'll notice your fingers get very crinkly. The reason is for that so that if you should always remember that wrinkling causes more surface area. So when you're wet or your fingers have been in water for a long period of time, they get wrinkly so that you can grip better. If they were just as firm as they were now, they'd slip on everything. So would your feet. But in areas where there's a lot of water or there could potentially be slippage, our fingers will wrinkle so that we are able to grip onto better. More surface area means that we have more areas so that we can actually attach to the surface of something. So that's why they get wrinkled. But as for our friction ridges, um, they are unique. For each person on this earth, they have a different friction ridge. Even if you are an identical twin, you both will have different fingerprints, always. There's very rare cases where there's the same, but typically they're always different. Um, and so on your fingers, just like remember your fingers are part of your integumentary system, at least the epidermis is. You have oil glands that are there that are going to secrete oil. So essentially, anytime you touch something, you leave a handprint there. Even if you don't see it, you're leaving a fingerprint because you have oil being produced on your fingers and actually all over your skin. So when you touch something, you're leaving an imprint of your hand. And so that's why they usually in investigative shows, they'll take powder and they'll brush it because that powder is attaching to the oils that were in your skin, and then they're able to make an impression of what your hand looked like. So even they're still fingerprint is still being used today to identify perpetrators or identify bodies and things of that nature. And so that's how we actually have fingerprints. They're actually friction ridges, and they come from, I believe, the dermis of our skin. Um, and so the actual term for the finger ridges, or when we use fingerprinting, is called dermoglyphics or glyphics. And so this is how we're actually able to see fingerprints. So there are three basic types of fingerprint patterns. So you have what's called an arch, which kind of goes up like this, and then you have whorls that go in a nice circle, which are really close to loops. But loops kind of go at an angle always, and they kind of make an oval shaped, versus whorl makes a nice round shaped. So I'll invite you to look at your fingertips. I only have one whorl, which is on on my right thumb, or excuse me, my left thumb, but everything else is either an arch or a loop. So I invite you to look at yours and actually see which ones yours are and compare yours to um, your your relatives, your brother, your sister, your husband, your wife, your partner, your spouse, and actually look at the different ridges, friction ridges that you actually have on your fingertips because no one has the same. There might be some similarities. There might even be you may have all three on one finger. So they're very, very unique, but they follow these three basic patterns. So going back into the dermis, we're actually going to look just a tad bit deeper. So we had our epidermis, which had the different layers of our basal, spinosum, granulosum, lucidum, and corneum. Now let's actually dive down into that next layer, which would be the dermis. Now the dermis has a few different things or organelles that are going to be found in here. Um, but the first thing first that we see here is this egg crate kind of membrane here, or ridges. So we have dermal ridges and then dermal papillae. And the reason that they are like this is so that it has a better grip and connection. So remember going back to chapter 5 with different tissues, we have connective tissues. So connective tissues are going to connect two different types of tissues together. So in between here, we're going to have areolar tissue, which if you remember from the chicken dissection video, um, they are going to, it's going to be that layer in between the skin and then the muscle tissue. Well, here it's actually in between our dermis and our epidermis. So if you notice that the epidermis is shaped like this, and then the dermis is shaped like this, is so that they lock into each other and create a really tight knit bond to each other. We want to keep our skin very, very connected to each other. So in the dermis layer, the dermis actually has a lot of dense, irregular connective tissue. If you remember from the dissection video, this was that very thin tissue that was wrapped around the bone. Um, irregular, dense, irregular connective tissue has a lot of collagen in there. And the reason it has, and especially for this layer, this is where all your scarring comes from. Anytime you have a scar, we notice that the skin is a little bit different after. It's a lot more either raised or it's shaped a little bit differently. That's because of this layer. There's a lot of collagen. And when collagen is going to repair itself or repair the cut, those collagen fibers are actually going to knit closer together and become like this, and it becomes stronger than what it was before. And so that's why scars are usually always raised, and then you can always tell you still have a scar because there's a lot of scar tissue. So scar tissue is just a lot of collagen fibers that have been exposed, and now they have wrapped a lot tighter and there's a lot more collagen in that place where you had that cut so that it makes it a lot more stronger. So collagen is one of the strongest fibers we have aside from keratin. But if we look here, so this layer we call the papillary layer, where those two epidermal ridges and dermal papillae actually meet. But in the reticular layer, we're going to have dense irregular tissue. So all this pink tissue that you're seeing here is dense irregular. And then here we can see we have our hair shaft, our tactical sensory, and then our veins and arteries. So we have a lot going on down in this region here. So usually when you get cut and you start bleeding, it's because you kind of cut into this layer here because there's not a lot of blood supply above here. But once you get into this layer in your dermis layer, you have a lot more blood supply. And so the book actually gives a good representation. So it kind of looks like an egg carton or kind of like a mattress pad, two putting together, of how they actually bind to each other. They actually fit like a puzzle piece, but they actually hold pretty tight together. So, if you've ever had surgery and they've actually had to cut through the skin, they can't just cut randomly. They actually have to follow what's called the lines of cleavage. So, if you look at this picture here, the collagen fibers within our skin actually follows a certain pattern. And so when they are going to make an incision to keep it from or reduce the amount of scarring that's going to happen, because scarring is going to happen regardless. However, if you cut against the grain, you'll have a lot more scarring. But if you cut along the lines, you'll reduce the scarring and you'll reduce the chance of you pulling that open. So also collagen is going to flow in the way that we naturally like bend, or that the skin naturally flows. But if you go against the grain, you actually are going to cause more collagen fibers to build up. And also you run the risk of pulling that wound open again, which is going to cause even more collagen to actually build. So if you look here, they actually have an incision that's perpendicular, which is going against the grain, because the grain is perpendicular going horizontally, but they made a cut going vertically, which means now this is a perpendicular, which means that there's going to be some scar tissue here, a lot of scar tissue, and it's going to potentially, um, it will prevent healing, and it will also prevent, or it'll also cause or potentially cause it to open back up because it is perpendicular. So anytime there's an incision that's being made, doctors and physicians and surgeons have to be aware of these lines of cleavage so that they know how to cut. So if you do have a surgery, or if like had your gallbladder taken out or your appendix, um, look at how the line is made, or the scar is, and it should follow these lines here. Um, So again, if you don't cut properly, you cause a lot more scarring. You'll still have scarring, but if you don't cut properly, it'll actually make it worse. So here you can actually see at the bottom here that they actually cut in the same way that these cleavage lines are actually laid. So this one here won't have as much collagen production, which means it can heal a lot quicker, and there's a less likely chance that it will actually get pulled apart, or the stitches will get pulled apart. And then we're down to tattoos. So, which makes me wonder how many people actually have tattoos and what's actually happening with the tattoo. If we remember from the epidermis, that when everything starts at the basal layer and then it pushes its way up into the corneum layer. So all those cells eventually are going to die off and then get essentially rubbed off and then fall off eventually. However, when you get a tattoo, it doesn't do the same thing. The reason is because the ink from the tattoo is actually going deeper than the epidermis. It's actually going into the dermis. So I personally do not have a tattoo, but I do have a tattoo, if that makes sense. So in my hand, which can't really see it, but there's a little dark spot right there in my palm where I was younger. I think I was in the third grade, and I accidentally grabbed a sharp pencil and it stabbed me in my hand. Apparently some of the graphite, which is what you write with, it's not lead anymore. We call it lead, but it's really graphite. It actually got stuck in the palm of my hand. And so essentially it got stuck in the dermis of my skin. So, and I can of course still see today. So that is technically a tattoo, even though it's not like I went to a tattoo parlor and got a tattoo, but this is still a tattoo because it works the same mechanism. So what's actually happening is that the dye gets in when you get a tattoo, an actual tattoo, the dye is going to the dermis. The dendrite cells, or that are the immune cells of your skin, they can't break up the ink. They actually die in the ink that has been put into your skin. And so what's going to happen is your immune system can't essentially break it apart. So all those immune cells are going to gather around the ink and contain it because your body recognizes that it's not your regular body cells that are being put into your skin, and it can't get it out. So the only thing it can do is contain it to protect it from the rest of the body. So that's one reason why skin or tattoos last so long, is because they can't go anywhere. The the body can't break it down and ship it out. And at the same time, the immune system doesn't want it just spreading. So it literally makes a guard around it and doesn't allow it to go anywhere. Um, Now, if a tattoo's not done properly, it can actually cause scar tissue. And I've seen a few, especially when I was in college. Some students actually rushed a fraternity and got a tattoo, and the tattoo artist went too deep into their skin, and that causes a lot of trauma. And so that can actually cause that collagen fiber in your dermis to become a lot really overactive and actually cause a scar. So instead of having a tattoo, now you have a scar. A tattoo is really just ink that has just been stained into the skin. But you can have a tattoo that essentially becomes a scar and you'll never get rid of it at that point. So there's a few ways you can get rid of a tattoo. There was older methods like dermabrasion, which is what it sounds like. It's abrasion of the dermis, which essentially is you really scrubbing or scraping the skin, which would be very, very, very painful. You have what's called cryosurgery, which essentially it's freezing the area that is tattooed, and it causes those cells to die, and causes the dermis to regenerate. We've gone away from that too. So what we usually do is lasers. So what lasers are going to essentially zap the tattoo and cause those cells that are stained to essentially break into bits and pieces. And then your immune cells, that's why you have to come back in several sessions. Depends on how big the tattoo is. You have to essentially have different sessions, but during after those sessions, that laser has broken that tattoo up, and then your immune cells can come along and actually scavenger and eat those cells and start breaking it down. If you remember, when you first get a tattoo, there's so much ink that the immune cells get essentially buried in it, and then try to contain it because they can't essentially break it down because it's so much. But with lasers, they are breaking it into little bitty bite-sized pieces, and then that allows for the immune cells to start breaking it up. And that's why you come into different sessions. If you ever get a tattoo removed, you have to do several different sessions. So it allows for the body to essentially metabolize the little ink and then dispose of it. Typically, usually lasers are pretty effective when it comes to tattoos. However, if you have a tattoo that is the color of, or if you have ink that's the color of green or red, sometimes you have issues with removing those tattoos because the laser that they use to actually break up the tattoo, some of the laser colors are red or green. So it's a little bit difficult for those colored lasers to break up the same color of ink. So usually if it's inks that are like blue or black, they're usually easier to break up. But if they're green or red, sometimes they have difficulty breaking up just because it's the same colors. That it doesn't go anywhere and potentially harm the body. So what you're actually seeing with tattoos is a reflection of the dermis layer. So you're actually seeing a bunch of clear cells, like a clear coat, that's on top of a painting that's deeper into your skin. So with the subcutaneous, which again, they do not consider the subcutaneous to be a part of the integumentary system. Um, this is due to it being full of adipose tissue or fat tissue. Um, However, it is really good when it comes to thermal insulation or retaining your heat. Um, some of the drugs, when I say drugs, I do mean medicines. All the medicines that we take are considered drugs. Um, some things are essentially injected into the subcutaneous layer, and they have to use what's called hypodermic needles, which makes sense because hypo means below, and dermic means dermis. So of course we're going below the dermis, which would be hypodermis. And so if we're able to inject drugs or medicines into this layer, it has a really high layer of vasculature or blood vessels that are going to allow for absorption of the drugs that are being administered. Um, Also with fat, depends on which hormones your bodies are producing. Under the influence of testosterone, fat tends to accumulate in the neck, like mine, or in the upper arms, around the stomach, the back, and the butt. So, especially like men who are kind of older and they have a lot more testosterone, um, you tend to see that the fat kind of settles in their stomach, or they have like what we call beer bellies. Um, I've even heard them called pot bellies sometimes, especially in, I guess, in males. However, in women, if you produce or people who use a lot of not testosterone, estrogen or progesterones, um, the fat tends to be a little bit thicker and tends to accumulate in the breast tissue, around the butt, and then in the hips and the thighs, which might actually seem right. So, I mean, if you look at you and compare yourself to others, it depends on which hormones that they produce. We'll notice, especially in males, we don't usually have a lot of fat in our hips, but women typically do. We don't have a lot of fat in our breast area, but women typically do. So there is some truth to this. There are some abnormalities. Some men can get more breast tissue or more fat tissue, in their breast area, but typically, usually, women usually get fat in the breast area in their hips and their thighs more than men do. And then also, water or skin protects from water loss. Um, so we can lose water in the terms of sweating, typically. Um, we can also lose water, which our skin is not that permeable, but it can allow water to seep out other ways as well. Especially like if you were in a sauna or a hot bath, your skin essentially sweat, but also it can lose water through the cells versus not just the sweat glands itself. But typically, we're going to lose it through sweating, which when we sweat, it's not just water, it's usually salts and other contents that flow with it. So essentially, the skin can actually help when it comes to electrolyte balance. Um, so it prevents us from losing a lot of our salts and sugars, especially if you've ever sweated a lot and after you finally cool down, your skin feels kind of gritty. Um, that is due to you actually losing salts with your sweat. That's why they say for you have to, when you are done sweating or working out, you have to drink something that's going to replace those electrolytes because you lose electrolytes in your sweat. Your electrolytes are your salts. So, like your sodium, your calciums, your potassiums, um, even glucose, you'll lose that in sweat. So that's why you have to drink it and replace it. But that's anytime you've ever sweat a lot, you'll actually sometimes even on your shirt, you'll even see little granules of salt that are left behind if you sweat enough. Also, when our skin is really responsible for conversion of vitamin D. So there's usually two places you can get vitamin D. Usually you can get it from the sun, which our skin can convert, and also we can get it from drinking things or eating things. In our milk, They actually put vitamin D in our milk. And the reason they do this is because in some countries, um, if you don't get enough, you can end up with what is called rickets, which is vitamin D deficiency. Um, with rickets, which I'll show you a picture. Yeah, let's see here. If you look here, this person's legs are bowed, which means essentially that they are vitamin D deficient. So the reason why we need vitamin D is so we can absorb calcium. The reason we need calcium is to make our bones, and we also need it for our nervous system conduction, or also our muscle function. But in order to absorb calcium, we have to have vitamin D. So our government actually puts vitamin D in our milk so that we can absorb the calcium that we get from the milk. Um, but we can also get it from being out in the sun. So if you spend 10 to 15 minutes of the sun out in the sun each day, you actually get your daily dose of vitamin D. So if you don't drink milk, which is fine, you can get it from another place. Now, during COVID, we saw a lot of vitamin D levels drop because a lot of us were staying inside the house and we weren't getting a lot of sunlight. So when we did blood works during COVID, a lot of our vitamin D levels had dropped, which is not necessarily a bad thing if it, as long as it stayed in a certain range. But if we start really dropping vitamin D, we're not able to absorb our calcium. If we're not able to absorb calcium, we can't make our bones properly, which makes our bones softer, which essentially could make our bones more fragile. And we don't want that to happen. We don't want our bones or our legs to snap in half as we're walking to and fro the grocery store or anywhere we're going. So vitamin D is very, very important. And skin is also able to convert compounds that we actually put on it as well. So, like hydrocortisone cream, our body is able to convert it in order to call or in order to alleviate a lot of the pain that we're having, or stop inflammation that we're having. So, the skin is actually very versatile. It's actually a lot of things we can do with the skin. Also, we can use patches, or there's some birth controls that are in patches that can absorb through the skin. There's nicotine patches that get absorbed through the skin. So the skin is still permeable. It still can allow things to go in and out. Remember, it's made out of cells, which has a membrane, so it's able to keep things in or out. Just like the skin is essentially one big plasma membrane for our body, it allows some things to go in and out as well. Um, Along with absorption or vitamin D synthesis, we can secrete. So some things that we secrete are going to be sweat, also oils. But the reason why we have to secrete oils is because if you've ever taken a shower and you've used soap, you might notice, you probably may have not, but your skin is actually kind of tighter when you get out the shower. And that's because you have stripped the oils out of your skin. Soap is going to strip the oils. That's what we use soap for. It strips the oils out of your skin, kind of out of your plasma membranes, and so it makes your skin kind of tight. And so that's one reason why we put lotion on after we get out the shower, because if we don't, we become what we call ashy, which is just exposing a lot of those dead skin cells because they're dried out now. Um, so that's one reason why we have to produce oils, is to keep our skin nice and stretchy. Um, Also, oil is going to help protect us from bacteria. Bacteria don't do very well in oil because some bacteria have to have oxygen, some don't, but some have to have oxygen in order to live. And with oil, you aren't going to live, it's going to kind of essentially suffocate the bacteria. Also, oil has a pH that's a little acidic. And so bacteria don't like acidic. Some bacteria don't like acidic areas, so it essentially kills them because it denatures some of the proteins in the plasma membrane. And so oil is actually a good thing. So we always think if your skin is oily, your hair is oily, and we think that's a bad thing. Sometimes actually that's actually a really good thing. It's actually helping us in a way. With sweating, not only when we sweat, we lose electrolytes or salts, but we also lose or urea, which is a nitrogenous base that comes from us breaking down amino acids. So a lot of the meats that we eat and proteins that we eat, the byproduct of those is urea, which is what is in our urine. Um, so that can come out of our sweat pores as well. So that's why sometimes you can kind of stink during after you have a workout, is because you're essentially giving that bacteria that's on your skin food. You're giving it electrolytes, you're giving it water, you're giving it a food source. Some of them feed off of urea, so you're actually feeding them. So that's why when you're sweating, especially in your armpits, around your armpits, those different types of apocrine glands that are going to secrete a lot of lipids and fats actually are feeding the bacteria, and you're actually smelling bacteria. That's what you're smelling. You're not smelling your sweat per se. You're smelling the bacteria that's feasting off of your sweat. And then oil, the actual term for oil is actually sebum, SEBUM, which is just a mixture of oily lipids. And so we have sebaceous glands on our skins, of course, and we also have sebaceous gland in our hair. That's actually going to help keep the hair from splitting. And so if you don't have a lot of oil in your hair, you tend to have split ends. And then we have absorption, which I mentioned earlier. So like nicotine patches and birth control patches, um, those can slowly penetrate the skin. Now the thing is, when we have patches or transdermal patches, they have to have a high concentration in order to continuously give a dose of that medicine or that substance, so that there can be a slow absorption into the skin. But this is another way we can administer medicines that we want to give slowly, because if you take any other route, if you give an IV medication, it goes straight into the bloodstream, which is really quickly. If you give it sublingual, it's really quickly. If you give them a shot, it's really quickly. If you give them a pill, it's still relatively quickly. But if you give them a patch, it takes a little bit slower time to have the effects. In some medicines, we want that to happen with. Our skin is also important when it comes to thermoregulation or temperature regulation. So if you are going to dilate your blood vessels, which means the blood vessels go from this to this, which means they're a lot wider, there's a lot more blood that can flow through there. If you vasoconstrict, you get a lot more closer, which means you limit the amount of blood supply. So to give you an example of this, this would be like when you're playing outside in the snow. Remember, all your blood is going to want to shunt to your vital organs. So essentially, that's why your fingers get cold, because your the blood vessels in your fingers and your face and your extremities, they are going to vasoconstrict, which means they're going to close the blood vessels. And when they close the blood vessels or they get smaller, there's not a lot of blood supply. It's only going to give enough blood supply to keep those cells alive, but it's not going to give enough to keep those cells warm. So it kind of sends your blood to your vital organs, like your lungs, your kidneys, your heart. Those are your vital organs, because it needs those to stay alive. You don't have to have your hands and feet to stay alive, but you have to have your heart and your lung and your liver to stay alive. So it goes through vasoconstriction. And so you might notice that your face gets a little bit more pale, which means that you're not having as much blood flow in your face. However, when you get done playing and you go inside and you get warmed up, those blood vessels dilate, which means they allow more blood to flow through. That's why your face gets a lot more redder during that time. Also, when you are outside exercising and your blood is pumping a lot more, you have a lot more blood flow through your face because you have vasodilation, which means that those blood vessels get a lot larger. Also, when they dilate, you are actually giving off a lot of heat, and your body's trying to get rid of heat. So it vasodilates, allowing for more blood to come through. Remember, blood is made out of a good portion of that is water, which water holds a lot of heat. So the way that your body can get rid of heat is by vasodilation, allowing more blood to flow through, which allows more heat to escape the body. So that's why when you're outside exercising, running, for people who are lighter complected, their face and their hands and their body is a lot more red, is because you have a lot more blood circulation and all your vasodilated, which means you have your blood vessels allow more blood to flow through to get rid of a lot more heat. So that's how our skin is able to regulate temperature, is by allowing our blood vessels to get bigger and smaller. And then our skin also has a new function, which is usually we have dendritic cells that are going to attack cells in our skin that can potentially be cancerous. So we have a few cells in our body that's actually trying to prevent cells from having cancer. So usually there's cells that are kind of going around scavenging if they find cells that are kind of getting out of order or starting to divide kind of funny or divide really abnormally, they'll kill it so that it doesn't tell any other cells to start doing the same thing. So we actually have cells in our body that's trying to prevent us from having cancer. But sometimes um, more cells overpower these immune cells, and then we end up seeing cancer come along. So that's what dendritic cells do. So when it comes to getting a tattoo, we are seeing dendritic cells actually get trapped, and so or actually are trying to form a wall around it so that that ink doesn't go anywhere. So that's actually due to dendritic cells. In our skin, we have different sensory receptions. So we have tactile sensory receptors that detect stimuli such as or touch and pressure. So in one of my videos, I'll talk about how if you touch your skin barely, there's a sensor for that. If you push deeper into your skin, you can feel that someone's giving a lot more pressure. If you fan your skin, there's another sensor for that. If you touch your skin with like a tack, there some receptors are very sensitive to that. If you paper cut yourself, that's a free nerve ending that you're feeling there. So there's a lot of different receptors in our skin that tells us if it's something's hot, sharp, cold, um, dull. So we have different receptors for everything that we can feel. We have a different receptor for. So within our nails, so here's a basic structure of how our nail is. So the edge that we see that's actually pushing above our finger is what's referred to as the free edge. And then we have what's called the nail fold, which is the portion that's on the side of our nails. That we also refer to as like the cuticle, which is actually at the top of our nail. The lunula, which is a funny word to kind of say sometimes. Some people have this and some people don't. Um, Usually it's this really white crescent moon shaped portion here. If you don't have it, no worries. Some people's are a lot more prominent. Some people's are back off in this region here. Um, if you do have it, it's just showing that that basal layer is actually pushing up against the nail bed or right under the nail. So essentially, there's no blood vessels that are in between here. It's kind of squishing the blood vessels. Um, Now, sometimes if you naturally do see this and it starts changing colors or it starts changing or it starts dwindling away, You might want to go see a dermatologist because that could be indicative of some type of disease or disorder that's happening. But if you don't have one, if you don't see one, and you never have seen one, it's no big worry. But if you naturally do have one and then it starts kind of going away, you might want to go see someone. So this is what our finger looks like if we were looking at it right now. But if we cut it in half, hopefully you don't. But if you ever cut it in half, this is what it would actually look like. So you have what's called the nail bed, which is the portion that's right underneath the nail itself, the part that it actually sits on, or the epidermis or the tissue that it sits on top of. And then you can see we still have the dermis and then the epidermis, the phalanx, which is the actual bone. You have what's called the nail root, just like we have roots of plants, which is the part that's underneath that you don't see. That's actually responsible for a lot of getting the nutrients and actually causing a lot more growth, where you have a lot more stem cells. This is the nail root. So if you've ever gotten a nail removed or broken a nail, um, or had a just in general just had a nail removed, there's a piece that's underneath here, which your nails don't just grow from the part that you see; they're actually growing from this part back here, underneath the cuticle that you can't see. It has what's called stem cells, just like we have in our skin, that are going to generate um, those nail cells. Now, when it comes to generating nail cells back in the nail root, those cells are very soft. But once they start getting closer, you start getting keratin pumped into them, just like in our skin cells, which is going to make it very hard. That's what makes our nails hard, is keratin. But when they're underneath the skin, they're really still pretty soft. So I had a friend in college that actually lost their nail. They fell and they lost their fingernail, um, and it broke off. However, it within about a month or two, it started kind of growing back, and that's because underneath here you have stem cells that are going to constantly make more cells. So even if you pulled off your nail, you'll eventually grow back because there's stem cells that are steadily growing those nails. It doesn't grow back the way it was for a few more months, but it essentially starts growing back. Now, with nails, there are a few disorders. Um, so if you skip down to the bottom here, we have onychomyosis, which is essentially where you kind of like fungus um, that has infected the cuticle. So, like back in this area here, there can be fungus that's going to essentially attack the stem cells. And once they get into the stem cells are what's going to make more nail cells. And by that happening, every cell that is made after that point, after being infected, will have that fungus. And so to treat those, sometimes it takes there's certain medicines you can take, but there's either you can take oral or you can put cream. And I believe cream works faster than oral, because oral has to get into the bloodstream and then it has to get into the stem cells. And I think it takes just a tad bit longer um, than cream does. And then you have like yellow nail syndrome. Um, and then you have what's called spoon nails. If you look closely, they have this big major dip into the nail, which actually gives it a spoon-like feature. And then here you have what's called Bowes lines, which if you look here, these have these really deep impressions that are horizontal impressions into the nail, like someone took a nail or some flat structure and actually kind of really hit the nail at the very tip. So there's this very deep impression, like someone kind of like stabbed it. So there's also what's called brittle nails, which essentially means that they're very, very easily broken. So especially if you use a lot of household products, if you do a lot of cleaning, like when I was younger, my nails I suffered from brittle nails because I was always cleaning, especially if you're using a lot of harsh chemicals. it causes your nails to essentially become very fragile and break. Um, and so if you're overexposing them, it could cause this. If you expose them to water a lot, you can essentially break down the nails and make it very easy to crack. Um, Ingrown nails, which a lot of people tend to suffer from, ingrown nails. Let's actually take a look at that. So if we look here, with ingrown nails, they start growing into the actual tissue, and they're supposed to grow nice and straight out of your toe. Instead, they kind of turn and start cutting into your toe tissue, and so eventually you can essentially cause which this one's a interesting picture. You can actually cause an infection, um, because essentially you're trapping bacteria. And so you can cause this by not cutting your toenails properly. And sometimes it can happen randomly. But if you, or also if you wear really tight shoes, which doesn't allow, which kind of jams your toe or jams your toenail into your toe, it can cause your toenails to grow kind of different or abnormally. You can have what's called nail pitting, which essentially it looks like a bunch of holes have been kind of chiseled into your nails. This is usually due to psoriasis, alopecia, dermatitis, or connective tissue disorders. So connective tissues run have a really big role to play within our skin. You can have what's called nail clubbing, which give you a picture here. This is what club fingernails would look like. Essentially, they're really wide and they kind of make this scooping or dome shaped nail. Um, this can be hereditary, but if you notice that they're just about as wide as the finger, um, they're a lot longer, and then they are, again, they're dome shaped. They're not flat like our nails are. They're very, looks like there's bowls, like a soup bowl that's on top of their fingernails, on top of their fingers. But nail clubbing can actually come from hypoxia, which is a low amount of oxygen. Um, it can be caused by smoking. It can be indicative of cardiovascular disease and diabetes. So if you know someone that has, or you see someone that has this, it's probably due to one of these few symptoms. And then the onychomyosis we saw earlier, which is like fungus starts to grow, and so they start turning yellow, and they have yellow nail syndrome, which um, can actually be a sign of respiratory disease and chronic bronchitis. So our fingernails can actually be a window to detect what type of illnesses that are going on. Same thing with our eyes. When doctors look into our eyes, they can see different types of diseases. They can see if you have there's I think there's kidney disease. You can tell someone has diabetes. If someone has an STD or sexually transmitted disease, you can even see this by looking at your eyes. So all of our body systems work together, and things can affect different body systems differently. But luckily, we understand, how things are able to react with one another. And so when we get deeper into our skin, which I mentioned this earlier with the erector pili muscle. So we have a ton of these muscles in our skin, but these are going to attach to the hair root. That's what's going to pull the hairs to make them stand up. And also, it's attached, if you notice here, it's attached to the bottom of the basal layer of the skin. So it's going to help tight, it's going to pull the skin at the same time that it pulls the hair because it has to have something to attach to, and it's going to pull the skin to make it tighter to retain heat. And usually at that same time, it pulls your hair to make it stand kind of straight up. But with the hair, we have the cuticle, which you've heard of a hair cuticle before. We have a cuticle, a medulla, and a cortex. Anytime you see medulla is actually the middle, and you can look here. That is the very middle. And around the medulla, there will always be a cortex, which means it's the outside of the medulla. You also have the hair follicle, which is this thick cell portion here, which if you notice that the hair follicle is going to run all the way around um, the root and the hair bulb, and it's going to actually extend into the basal layer and the spinosum layer of the dermis or into the epidermis. So that's one reason why if you ever try to pull a hair, it's really hard and it really tugs because it's attached to a muscle. It's attached to a lot of different sensory. If you look down here, there's a lot of tactile sensory that's attached to, and it's also attached partially to your epidermis. So you're pulling a lot. So when you get like a bikini wax or you're just plucking a hair, there's a lot it has to get plucked through in order to come out. And it's attached to a lot of things. That's one reason it hurts so much. Especially if you just try to pull one hair by one, it's a lot. And they kind of actually have a lot of strength to pull. You'll have to need a lot of strength to pull them out. That's one reason it's kind of hard to pull hairs. That's why usually if you wax, you have to get something that's going to cover the surface area, that's going to grip to them very well so that it can pull. So that's when they pull, it's going to be very hurtful when it gets pulled because you're pulling a lot of tissue. You have a lot of nervous system that's down here. And so here on the right hand side, this is actually giving you a cut of what it would look like if we took a hair out of a human being. And here you can still see your medulla, your cortex, all these little white dots. If you look, if you remember from tissues, this is going to be your adipose tissue. That's over here. And here you have your hair sheath and your hair root, which here you can see the root down here. And so all this is the root. So your hair that's above the skin is your shaft, but the hair that is all below the epidermis and the dermis is going to be your hair root. Now, when you're pulling a hair, remember hair has stem cells as well, and hair is going to start off soft, and then it's going to add keratin that's going to make it hard. And once it starts pushing out of this region here, is those hair cells are going to die. So the hair that we see on our head is actually dead hair cells. It's dead after it induces keratin to it, just like the skin. It's going to die once it starts pushing it out. So functions of the hair. So not only does it make us look pretty, um, it has a few different things it has to do with, um, especially like when it comes to protection. Um, especially like our hair for African Americans, our hair is a lot more coarse and darker. It is for protecting us from UV radiation. So for a lot of our ancestors came from Africa, which was a well lit area and very hot and very had a lot of radiation or UV light. And so our hair is really coarse and it is for protection or protecting our body and our scalps from the sun. Heat retention. So if you have a lot more hair, especially like with animals, if they have a lot more hair, it's for retaining their heat, especially in the wintertime. Now, like for some dogs, in the summertime, they shed a lot more is because they're trying to get rid of hair so that they can cool down. So it's the same thing. But more importantly, our hair is morely used for sensory reception. And so if you remember from the picture above, we have a lot of senses that are happening out here. We have a lot of different types of tactile senses that are happening. And so hair is really for tactile. And then also we can also we can also determine someone's age by their hair. Now, usually we're only able to determine someone's age um, once they start getting into their 40s and upper, and it also depends on genetics because some people can gray earlier than others, which is what leads us into our next part. As people age, they tend to lose their pigment of their hair, and so once they start losing it slightly, their hair becomes what we refer to as gray, which is the gradual reduction of melanin. But then once it loses all of its melanin production and it can't produce any more melanin, we call it white. Now, even if a person has white or gray hair, their hair is still growing, it's just not producing pigment. So even if they're older and they have white hair, their hair still grows. It just doesn't have any color to it. It's just white at that point. But when it comes to hair growth, there's different stages of hair growth. So you have what's called the anagen phase, which is where it's an active phase where living cells of the hair bulb are growing very quickly. This cycle usually happens and it lasts for about 18 months to 7 years. So this is a very long active stage of hair. And then you can get what's into the next stage, which is called the catagen phase, which is essentially kind of takes a break for about 3 to 4 weeks and kind of recuperates. And then it goes into what's the telogen phase, which essentially um, it can stop for a long period of time, for about 3 to 4 months, and then I'll essentially go back into the anagen phase. So you have the anagen, catagen, and telogen phase. So it kind of works for a long period of time, or your hair grows for a long period of time, and then it kind of takes a break, and then it can kind of go back, and then sometimes it takes a longer break, and then it'll essentially start going back. On average, your hair grows about half a centimeter to a whole centimeter per month. So it can take about 3 months for you to grow on average, about 2.5 inches of hair. For me, that's a lot, but for some people who have naturally long hair, you probably maybe cut your hair maybe every 6 months, maybe, or maybe once a year. So hair is actively growing every single day. To us, it may not seem like a lot, but as in microscopic as our hair is, it's a lot that is actually growing per day. And it can vary between ethnicities and genetics. Some people grow hair faster than others. So there's a lot of other factors. So that's one reason why it says zero point 0.5 to 1 point centimeters per month is because it just varies. But what's really interesting is that we can lose from about 10 to 100 hairs per day, which is pretty crazy. But, and you probably don't realize how many hairs you actually have on your body. But I invite you to go look at your lint trap in your dryer or also in the shower. Those are the two places where we tend to catch a lot of hair. In the shower is because, of course, we're showering, and so all of our body is covered in hair, and so it usually gets caught in the drain or it's left at the bottom of the bathtub. But especially what I've noticed is if you use towels to dry off with, like big towels, and you wash them in the dryer lint, especially like in the corner of your dryer lint, there will be a collection of hair from when you have dried off your body. So we lose a ton of hair each day and just don't realize it. Anytime you sit down somewhere or you're walking somewhere, hairs can fall off. And sometimes you don't even, most times you probably don't even notice it. But we are constantly leaving dead skin cells and hair cells everywhere we go. So we kind of leave. And what's really interesting is that our hair and our skin cells lose their nucleus after keratin has taken its place. And so it's not like we're leaving DNA, um, but we kind of leave a piece of us everywhere we go, essentially. Now, with hair growth, we can have a lot of hair growth or we can have a little hair growth. So we can have what's called alopecia, kind of like what Jada Pinkett Smith is suffering from, or Will Smith's wife. She is currently bald. Is because she suffers a condition called alopecia. But usually alopecia is really spot baldness. So you have parts of your hair that starts going bald. It's an autoimmune disorder where your immune cells of your body is going to essentially mistaken the keratin of your cells. It's going to mistake that as foreign and then it starts attacking them. So if it starts attacking them, it starts killing them off, and then you're not able to produce keratin, and so their hair doesn't really produce very well. And essentially, you start losing your hair. Now you can have what's called diffuse hair loss, which is a lot more dramatic, where you start having your like all parts of your hair and your scalp start shedding off, and you start also across your body, you start losing it. You can have what's called male pattern baldness, which is what you see in men that have a horseshoe type of baldness, or they have this big bald spot in the back of their head. That's actually genetic. Um, and what's really interesting about people don't know is that women carry that gene. So if my dad was bald, that does not necessarily mean that I'm going to be bald. However, if my mother carries that gene, which luckily she does not, so I'll have hair for the rest of my life. But if my mother carried that gene, does not necessarily mean that my mother's bald, but my mother carries that gene for baldness. It gets passed down to me, and I would have it. That's if she had baldness. But lately she does not have it. But if she did, I would get that gene, and that's how I would become bald. So anytime someone is bald, or has a male pattern baldness, that's actually a gene that comes from women. It actually comes from the mother, not from the dad. So anytime a man is bald, is actually because of his mother, unfortunately. And so here it gives a little bit more in depth um, of your sweat glands and your hair follicles. So here we can see your merocrine glands and then your apocrine glands. Merocrine glands are going to be more abundant than apocrine. Apocrine glands are going to be a lot wider and they're a lot fewer. Apocrine glands are only found in your armpits, around the mammary glands or your breast tissue, and in your pubic area or your down south area. Those are the only places where you'll find apocrine glands. And those are going to be, you can remember that because usually that's the places where you're going to be the most stinky, is because you have apocrine glands that are going to secrete lipids and other fatty fuels for bacteria, and bacteria like to feast on that, and then bacteria is what's going to make that funky smell, and so that's going to be due to apocrine glands. Merocrine glands are going to be the most abundant in your body. They just secrete regular sweat like water and salts, and so those are all across your body. But apocrine glands are going to be the only ones that are going to be found in your regions like your armpits and your breast and around your pubic area. So acne, which uh, pretty much everyone has probably suffered from it. If you haven't, count yourself lucky. But most of us really suffered from it during our puberty years. So around about 13, 15 range. I think I probably was from the 13 range. So there's different types of acne. Um, Especially, and some people are still dealing with it now. So if you, especially during menstruation, usually you see a boost of hormones, just like in puberty. So typically, usually, some females are able to or identify that they are getting ready to start their menstruative cycle because they see a pop up of acne. Um, so here we have a few different types of acne. So you may have heard of a blackhead. Um, Essentially, a blackhead and whitehead are the same thing, except for a blackhead, the top has been exposed or has ruptured, and there has air. from the outside world has gotten into that pustule. And so we essentially it oxidizes that pus, and so it becomes black. So with the whitehead, it hasn't popped, and so it's still underneath the skin. If you look closely, it's still underneath the skin. But with a blackhead, it has popped open and it's been exposed to the air that's out here, and so it has oxidized it. So that's really the only difference. That's why it's called an open comedo and then a closed comedo. A pustule, it's similar to a whitehead, but it's a lot more deeper and it has a lot more going in depth. It actually goes, you can't even see the rectal pili. It actually goes a lot more deeper, and it's starting. You actually see there's a lot more infection happening here, inflammation happening. And a nodule kind of just is even worse. It goes a lot more further, and actually can cause the hair follicle to rupture. You can see that it actually spreads down to the very almost to the base of it, and it can potentially rupture a hair follicle. And then a cyst is just a fluid filled pocket of fluid that can potentially rupture. We tend to hear more cyst. I hear more cyst about like ovarian cyst, but cysts are just pockets of fluid that are encapsulated and could essentially burst. Um, with acne, essentially it can be skin cells and oils that get trapped into this area. Also, it can be skin cells, oils, or white blood cells. So anytime you see pus, when you think of pus or when you get ready to pop a whitehead, what you're really seeing is white blood cells and skin cells and oil all mixed in together, which what gives it its color. So if pus is white, you see a lot of white um, blood cells or your immune cells collected there trying to kill or have died killing the pathogen or bacteria that has invaded the skin or that the skin is trying to get rid of. And so that is one reason why we have acne is because our body's trying to get rid of something. So, um, especially one reason why it makes a head or a bump is because it's easier to push out pus or bacteria out of the body this way than trying to take it back into the body, possibly put it into the bloodstream. If you put it into the bloodstream, you're going to essentially have sepsis, which just means that you have white blood cells or bacteria in the blood that's not supposed to be there and can potentially get sent to the rest of the body, cause more infection. So it's actually easier for the skin just to push it out of the skin versus trying to put it back into the body and potentially cause a lot more harm than helping it. And then in our ears, we have what's called ceruminous glands, which it produces cerumen, which is the medical term for our earwax. So our earwax is going to protect our eardrum or the acoustic meatus, and it actually protects from pathogens and it helps kind of lubricate the eardrum of our ear as well, because that's a very sensitive area that we have. So you have to keep it moisturized, and you also got to keep it protected from getting infected. Um, Also, so mammary glands or the glands that produce milk are just modified sweat glands. So the milk that we drink, which we're the only mammals that drink milk from other mammals, the milk that we drink is actually sweat. And that might gross some of you out, but you have to think about it. The only thing that our body really secretes, or from the skin, or rather, or from glands, are going to either be some type of hormones, um, lipids, or oils, or sweat. That's the only thing that our body secretes. So milk is just sweat, unfortunately. Um, which now you understand that when we drink like whole milk, it's actually saying that it's full of fat. Well, the our apocrine glands secrete lipids, so it is actually secreting fatty water, essentially, or fatty substances, which what we call milk. So That's why we say whole milk. It's because it has all the fat in it. If you drink 2%, it only has 2% of the fat in it. So that's how we actually get um, milk. It's actually sweat. So with skin, we have what's called regeneration. So cells are essentially going to divide and make more of themselves to replace themselves when they get ready to die. Um, Especially when it comes to like scar tissue, those are tissue cells that have died, and so they have to replace themselves. And sometimes if you cut too deep, you can call essentially it's called fibrosis, where you have a lot more fiber or fibroblasts producing collagen. That's essentially that's going to heal that. So anytime you have a scar, that means you've cut into the dermis, and in order for the body to heal itself, it's going to produce a lot more collagen so that it can essentially bind a lot more harder so that it makes it stronger than what it was before to prevent it from separating or splitting. Essentially, it just wants to make it as strong as it possibly can. So that's the point of scarring or healing. So here it gives us a picture of there being a wound. And then you see here, you see that these are leukocytes, which are just white blood cells that are going to come and clean this area. And then once it's done cleaning that area, you're going to see fibroblasts, which fibroblasts are going to be, anytime you see blast, it's going to mean building. And then the prefix is fibro. So these are fiber building cells that are going to come in here and start making fibers or secreting collagen. And as we're going to essentially start clotting, which is going to make a scab. But underneath here, we see these collagen fibers and these fibroblasts making collagen that's going to start making this a lot tougher. If you look at this tissue here versus this tissue that it just regenerated, this is a lot more collagen that's right here, which means it's going to be a lot more stronger. And so it's going to make it a lot, it's going to cause a scar. So that's what scar tissue is just an abundance of collagen fibers. And then psoriasis. So if we look at this here, so it's I believe, an autoimmune disorder where essentially it's going to cause your skin to start making more skin. And so it starts making it faster than your body's used to. And so it starts pushing it up to different layers. And essentially that skin cell, remember, is dead and becomes really flaky and patchy. And so it's not contagious or anything. It's just that skin cells just really dry. It's going to be flaky. It can potentially cause a lot of pain and irritation to people who have it. Um, so the patches are actually called plaques. Um, and so it's actually attacking the keratinocytes and causing rapid growth. So people who actually have nail pitting, um, actually runs in line with this. So that's one way to kind of tell if someone has this. They usually typically have nail pitting as well. Um, they can be treated for this, but there's really not a cure. But so they can be given treatments or creams or topical corticosteroids, um, electrolyte electrolyte ultraviolet light therapy, and certain oral medications that can alleviate the symptoms, that can try to contain this, but typically you usually always have a flare up. Um, some people get kind of embarrassed about this. There's been some commercials about it, but um, typically some medicines can contain it, but typically it just reduces the amount of flare ups that you have usually. And then burns. So there's usually three different stages of burning. So you have first degree, second degree, and third degree. So first degree would be your common sunburns. So if you get a sunburn, that's a first degree. It's still burning your skin and is still kind of mutating your DNA a little bit. It is still causing structural changes to it. However, it takes probably about 3 to 4 days, maybe to a week or two, for it to fully heal. So it's not that bad. So that's one reason where it's referred to as first degree. Second degree, you have burned the epidermis and the dermis, or at least a good little portion of the dermis. And you can see here in this picture here that he has significant burning and it has kind of touched the dermis. And you see a little bit of blistering. In third degree, you can see it has burned past the epidermis, the dermis, and is actually working into the subcutaneous level or deep into the dermis level. So this would be the third degree. So here it explains that first degree is like superficial. Second degree includes the epidermis and part of the dermis versus third degree. Usually it's the subcutaneous layer where the epidermis, dermis, and subcutaneous layer are actually destroyed. Typically, if you have a third degree burn, you have to have what's called a skin graft, which I believe I talked about in the tissues chapter, where you have to get tissues from different parts of the body or skin from the different parts of the body to get it to grow and take it off and then put it in the places where it has essentially been burned. So to explain this, it'd be like if I got a bad burn on my arm, I'd have to take some skin from my leg and put it on my arm so that I could regrow skin tissue because I have burnt off a lot of my tissue. So you have to have cells to rebuild from previous cells. If I have gotten rid of all those cells, I can't replace those cells because I don't have any cells anymore. So I have to have a skin graft. Um, there has even been skin grafts with using fish, like taking like skin from fish and actually using it to graft because it's kind of similar to our skin in a way. So you can take skin from other animals and it can sometimes work. Um, just in case that there was too much skin that was burnt off. So you have to get skin from other places or other animals, essentially, or other people. Um, Anytime there is a burn, which especially like here, you never pop the bubble, even though you're tempted, never pop the bubble because it holds a lot of water. Um, People who do get burned run the risk of losing water because their skin is now exposed. Remember, your skin is permeable, but it keeps things in, it keeps things out. So if you were to pop this, you'd allow water to go out of it. Also, this is really good for healing. So do not pop this bubble, even though it's very tempting, but don't pop it. Um, it especially burn victims are at very high risk for losing a lot of water because now they've exposed their skin um, and burnt it off. So they have to be careful. Now, when it comes to determining how severe the burns are or how much area has been lost, you follow what's called the rule of nines. Um, so each of the part of the body is divided into either nine or multiples of nine. And so if you burn um, a good portion of the anterior trunk, that's going to be 18%. If you burn the arm tissue, if you lost a lot of arm tissues, that's 9%. Um, the only time that it's lower than 9% is going to be the perineum, which is around the pubic area. However, in children or infants, it changes a little bit. You have 9, 18, 14, and then, of course, 1. So it changes, depends on if it's an infant or a adult, but it's just really referencing the body surface that is being affected by the burning of how much body surface or surface area that has been affected or burned. And so we always use the rule of nines. And then sometimes when we are treating patients or burn victims, we have to do a debridement, which essentially we have to scrape off the dead tissue, which is going to promote the growth of new tissue, and also it prevents it also when we're scraping off the old tissue, we're also getting rid of some of the bacteria or pathogens that could possibly be with it. So if you ever work in wound care, anytime there's a wound, they have to go in there and kind of scratch it a little bit, which is going to cause more bleeding, which is going to provide more healing, which is also going to provide more collagen growth, which is going to start closing that wound up. So with burn victims, we had to be very patient, but there was a lot of work. Botox. So there's different types of Botox. You usually hear about Botox when people are trying to control wrinkling. Um, However, Botox is not only used for wrinkling, but it can also be used to treat migraines. It can also be used to prevent sweating because it essentially it blocks the nerve signals. So our nervous system is actually responsible for us causing muscle contraction. It's also going to cause us to sweat, and also it's responsible for causing migraines. So there's a lot of different functions for Botox, but Botox actually comes from a bacteria. It's actually a neurotoxin that's produced by a bacteria. Actually referred to as Clostridium botulinum. So it's a botulinum toxin. So the bacteria essentially produces a toxin, and we collect that toxin, and we were able to administer it carefully um, to muscles to prevent wrinkles. But one thing with Botox, it only lasts about 4 months, and so you have to come back every so often. So if you're that worried about wrinkles, of course use Botox. But some people use it for other reasons, like if they have excessive sweating or really bad migraines. Typically, Botox will actually help with that. And here are some different types of skin cancer. You have basal cell cancer, which just means that the basal layer of the stem cells essentially are going kind of bonkers, which means you can have just a lesion, which is just a few cells that are going out of whack. Or you can have squamous cell carcinoma, which means that these cells in the spinosum layer um, are having issues, are dividing more, or potentially getting ready to become cancerous. Or you can have what's called a malignant melanoma, which is the most deadly type of skin cancer because it's very aggressive and it can metastasize and move to other different skin cells. So here are the ABCD rule for when it comes to melanomas. So A equals asymmetry, which is 1/2 of a mole or the birthmark that does not match the other. Border, we look at edges. So are they notched, irregular, blurred, or ragged? C is for color. Is the color uniform or does it change different colors? The diameter, which is what I talked about at the beginning, does it change sizes? Is it bigger than 6 millimeters or 1/4 of an inch, or is it continuing to grow? And then E is for evolving, which means changing in size, shape, color. Does the mole feel itchy, tender? Does it start bleeding? So these are the ABCDEs of looking for skin cancer. So I know there's a lot, but the integumentary system has a lot to offer. There's a lot that happens within the integumentary system. Hopefully you learned something new. I know this was a very, very long lecture series, but there was a lot of information that happens, and the integumentary system is very important and vital to us. So hopefully you learn something new, and we'll catch you next go.